Okay, guys, here we go, day 2, the derivative. So we'll talk about what the derivative is in a sec, but first let's give you guys a challenge question. I want you to evaluate f of x equals f of x plus h minus f of x divided by h, using f of x as 3x squared, which we all know is a parabola. Remember what this is. The difference quotient, which I circled here, is the slope of a secant line between 2 points. So we want to think of this difference quotient from yesterday as a slope machine. Okay, it'll allow us to find the slope at any given x value. Okay, so you guys go ahead and you can pause and you can do it. I already did it for you, so go ahead and try. Okay, so there we go. I wound up with 2x plus 3h. Hopefully you did as well. Okay, so I do want to just remind you of something that we've done this year earlier that will come up today, and then we'll get into the derivative. So it says, remember, what if I give you a point and I give you a slope? And I wanted you to write the equation of a line. So remember, there were two ways to do it. We could go old school from geometry and do y equals mx plus b, or we could use our point slope formula, which, since I have a point and the slope, this would be the best way to do it. This will come up later today. Okay, so we'll just substitute in. So y minus 2, right? Here's my x1 and my y2. I'm sorry, x1, y1. Y minus 2 equals the slope times x. So minus negative 6, that'll become a plus 6. And there's my equation of a line. No need to simplify or do anything else. Solve for y. You don't have to do anything like that. Okay, so that'll come up today a little bit. All right, so let's get into today. What is this derivative? Okay, so watch. So let's look at this little diagram right here. And I didn't fill everything out, so I figured we could do some of it together. Okay. All right, so first thing I want to do is I want to write the coordinates of this point right here, point P. So I go over a distance of x, right, and I go up a distance of f of x, which makes sense, right? If I had a function and x was 3 and I wanted to know what y was, I would do f of 3. Okay, now I'm going to go and move a distance of h, right? So that's why I wind up with x plus h. And then if my x value is x plus h, it makes sense then that my y value would be, right, subbing in x plus h into the f function. So f of x plus h, which we looked a little bit of this yesterday. Okay, so here's what I want to do. So what happens if I take that h value and I keep making it smaller? Okay, I see how I keep making that smaller. My secant line eventually becomes a tangent line when that distance becomes a distance of 0. So as h approaches 0, so that distance gets smaller and smaller, the secant line becomes a tangent line. And from the past, very important, at any given point, there is only one tangent line. One tangent line can be drawn at any given point, okay, as we can see that on a curve. Okay. Alrighty, so here's the definition of a derivative. The derivative is when you take that difference quotient, which, remember, that's just the slope, it's the average rate of change, but you're going to take the limit as h approaches 0. So what happens as that value becomes smaller and smaller? This is called the derivative, and this will create, again, the slope machine. It says the slope of a tangent line to a given function at any point. So this is one definition. I'm just giving you a whole bunch of definitions of a derivative. Okay, so the first one, the slope of a tangent line to a function at any given point. The slope of a curve at any given point. And here's the big one, instantaneous rate of change. Before, when we were doing a secant line, we were doing the average rate of change. Now when it becomes a tangent line, we're only going to have one point. So it's going to be the instantaneous rate of change of y with respect to x. The domain, which is the x values of the derivative, consists of all x where the limit exists. And then this is used to later, next year for some of you guys, to use to study rates of change in all kinds of real life apps. Okay, so let's get started doing this. Okay, so we're going to find the derivative of f of x equals x squared plus 1 using the definition. So remember what this means when we're finding the derivative. We're really just finding the slope of a tangent line at any given x value. It's the slope machine. Okay, so f prime of x is equal to, and we can use that to denote the derivative. Okay, so f prime of x is equal to the limit as h approaches 0 of the difference quotient. And now remember from limits in the last unit, if I plug in my 0 up there, right, I am going to wind up with a constant over 0, right? So that's no good. So we need to simplify this somehow. Okay, so let's go ahead and do our derivative here. So I'm going to leave off, no, I probably should keep writing it. All right, it's our first one, we should do it right. So the limit as h approaches 0. So I'm going to plug in x plus h, right, into the function every place I see an x. And then I'm going to subtract off the function over h. I'll go off to the side here and do x plus h times x plus h. So we get x squared plus 2xh plus h squared. Okay, so let's come back here. The limit as h approaches 0, x squared plus 2xh plus h squared plus 1, right? And now I'll distribute that negative, minus x squared minus 1 over h. And then we'll combine like terms. So the x squared and the negative x squared wipe out. The 1 and the negative 1 wipe out. I'll make a little more room. Okay, so we're left with the derivative is equal to the limit as h approaches 0 of 2xh plus h squared over h. And then we're just going to reduce here. We'll simplify. You want to take out an h, you can. We're left with 2x plus h over h, right? Go ahead and wipe out. So the limit as h approaches 0 of 2x plus h. Now go ahead, just like we did, in our limit unit, go ahead and plug in. And now f prime of x is equal to 2x, right? If you were to sub in 0 right there. Okay, so this guy right here is my slope machine. It will allow me to find the slope of the tangent line at any given x value to this parabola of x squared plus 1. Okay, so now I'm going to show you how we can use it. Because remember, we're finding the slope of a tangent line. That's instantaneous rate of change. Slope, we normally have 2 points. So we've never done something like this before. Okay, so here we go. So I took that x squared plus 1, which we just did, and I graphed it, and here's what it looks like. And now I want to use the derivative. So I'm using a lot of new words here, right? I want to use the derivative. This is the derivative, f prime of x, y prime of x. Use that to find the slope of a tangent line at x equals 2. So let's see, x equals 2, it looks like it would hit somewhere right up here, right? And I want to find the slope of that tangent line at x equals 2. So I'm just going to plug in. So the slope of that line is 4, which it looks like that red line could be 4, right? All right, let's do it at x equals 0. Okay, so at x equals 0 right here. All right, at x equals 0, to me it looks like the tangent line is going to be a straight line going across. Let's plug in and see. So 2 times 0. Yep, that's a 0 slope. And then let's do negative 2. So at negative 2, looks like it's up here somewhere, right? So the slope of the tangent line. So let's plug in negative 2. And there we go. So this is called instantaneous rate of change. Okay, we use the derivative to find the slope of the tangent line at any given x value. And how do we do that? We use the difference quotient, but we take the limit as h approaches 0. Okay, so now let's just go a little bit further. Now, instead of just finding the slope of the tangent line, I want us to write the equation of the tangent line. So, so really what we're doing is just writing the equation now of like that red, purple, and green line. Okay, but I'm probably starting with it. I'm giving something different, yeah. Okay, so let's write the equation of the tangent line. Here's how we do it. So the first thing, again, we're going to find the derivative, right, f prime of x, and use it to find the slope of that tangent line at any given x. Then we're going to plug the x value into the original, and this will give us a point on that tangent line, because remember, we do need to have a point. And then we'll just use the point slope formula. All right, so here we go. And we're going to do this at x equals 4. All right, so here's what I'm going to suggest. First, let's just go over to the side so we remember what it is our ultimate goal is, right? Our ultimate goal is to write the equation of this tangent line. So I need a point and I need a slope, right? Those are the two things I need. So we need a point and then we need the slope. And then we're going to use the point slope formula. So this is what my ultimate goal is here. Okay, this is what I have to do. So usually I like to just find the point first and get that done with. Okay, so my x value is 4, right? And then if I plug 4 in, right, into that square root of 4 is 2. So there's my point. So you might as well just get that point, you know, before we start. Okay, now let's go ahead and do, get our slope machine, and we'll find what that slope actually is at 4. Alrighty. Okay, so we'll take the limit as h approaches 0. I'm going to plug x plus h into the function. So this is going to be the square root of x plus h minus the function itself over h. Okay, so again, you can see if you plug in 0, you're getting 0 on the bottom. That's no good. So we need to alter this. We need to change it like we did in our limit unit. So we're going to rationalize the numerator, right? That's the only thing we can do. There's no simplifying in any other way. So I'll multiply by the conjugate like we did in the last unit. So x plus h plus rad x over rad x plus h plus rad x. I'll put parentheses around everybody. Limit as h approaches 0. Okay, so here we have on top, we can treat it like dots, right? Take the first one and square it. So we're left with x plus h. Take the second one and square it. Put a minus sign between them. And then after everything simplifies, oopsie. I forgot to get this guy in here. Okay, a little more room. Okay, so on top, our x's cancel. We're left with h over this guy. Remember, don't distribute because nice little cancels will happen. Right, these guys are gone. Whoa, this marker is getting fat. So the limit as h approaches 0 of 1 over rad x plus h plus rad x. So now if we just sub in 0, okay, if we plug in 0, we're left with 1 over rad x plus rad x. So we're left with 1 over 2 rad x. Okay, so that's our slope machine. This is what's going to allow us to find the slope of a tangent line at any given x value. But in this particular problem, we are looking at x equals 3, okay? So now I want to know what this m value is right here. Oh, why isn't this working? Sorry. Let me try again. Okay, right here, I want to find this m value. So if I look at x equals 4 and plug that in down here. Sorry, this is hard to do this correctly. All right. Okay, stay. Sorry, guys. Okay, technical difficulties on my part. So 1 over 2 times rad 4. So we're left with 1/4, and that's going to be my slope. So now I can go back up. I can plug in 1/4 right here. And now since I have the point, I have the slope, I can write the equation of that tangent line. So y minus 2 equals the slope times x minus 4. Okay, and that is the equation of the slope of the tangent line. Woo! All right, fun stuff here. Remember, you can pause, rewind, try the question again, whatever you like. All right, so let's practice that same exact thing again. I was going to let you guys just do it yourselves, but I don't know. I feel like maybe we should do it. Whoa, my dog is snoring. I don't know if you heard that. Okay, so let's do the same thing. Let's write the equation of the tangent line to f of x at 3x squared plus 5. So essentially we're finding the instantaneous rate of change at x equals -2. And we're going to use the definition of the derivative again. So like I said before, I like to kind of organize it, like what is my ultimate goal here? So remember, my ultimate goal is writing the equation of a line. So I need, I think I put the point first before. So I need a point, and I need the slope. And then I'm going to plug into point slope formula. Y minus y1 equals m times x minus x1.